Welcome back to our Well AP course. Now, in previous episodes, we talked a lot about sensor testing, continuous monitors, and performance verification, the difference in pros and cons between these. Now, obviously, I am a big believer in using continuous monitors and sensor data to achieve points within the well building standard, rather than the more traditional method of performance verification. But there is one big caveat here, which is that you need to have the right monitor. The monitor needs to be compliant with the performance guidebook within well, and it needs to actually measure all of the things so that you don't need performance verification anymore. What you don't want to do is end up with monitors on the wall that give you some points, but then also need to do a whole bunch of performance testing because the monitors were not entirely compliant. In that case, you're kind of losing on both fronts because you're spending money on both of them when really you could be getting away with one or the other. So at a most basic level, you need to ensure that the monitor that you are using removes the need for performance testing on A01, right? That's feature A01, and specifically part 5 within that. And that means that you need to choose a monitor that measures PM2.5, PM10, TVOC, CO, and O3. So that's carbon monoxide and ozone, those last two. And if you really want to get maximum return for the investment on sensors, you also want that monitor to measure CO2, carbon dioxide, as well as NO2. CO2 is going to give you points under A03 and A06, so that's around ventilation, while NO2 is going to give you a bonus point under feature A05. So by measuring all of those parameters, you are able to sort of get maximum bang for buck. That's the parameters piece. For the rest of this episode, we are going to jump into the performance verification guidebook and actually look at the requirements for these monitors, because you cannot simply go on Amazon, find a device that says that it measures some of these things, put it in the building, and cross your fingers to hope that everything works out. There are a lot of different types of air quality monitors on the market, from very, very cheap devices that maybe just give you a general indicator of overall air quality, to lab-grade instruments, to commercial monitors in the middle, and a whole range of other things. And so the Performance Verification Guidebook has a lot of detail about what the requirements of these monitors are. So let's jump into that. So this is the Performance Verification Guidebook. It's a document you will probably become intimately familiar with if you are not already. And the first thing that I want to point out is that this document, well, number one, it's updated at somewhat regular intervals. And so it's important to make sure that you are looking at a recent version. The other thing is that, and this is where I often see people getting confused, is that they will sort of look through here and immediately think, I'm doing the air concept, let me look at air. And they'll jump maybe to page 8, and they will start reading about the requirements of devices here. This is for performance testing. And if we scroll back up to the top, you'll see that this is under performance testing, and you've actually got continuous monitoring, which starts on page 34. So I see a lot of people actually reading the wrong part of the guidebook and making decisions and creating specifications for their project based on entirely the wrong part. They're looking for continuous sensors, but they're actually looking at the requirements of performance testing. So with that, we want to jump to page 36 to look at the hardware requirements. And we're just going to sort of go through these one by one, because this is if you're going for a well project, this is the truth. This is what you want to follow to make sure that you are choosing the right device. Number one is making sure that the measurements are continuous. We are talking about continuous monitoring, after all. So measurements are taken at intervals not longer than 1 hour for radon. But again, radon, as I talked about in an earlier episode, it is almost never necessary. If you have a mechanically ventilated building that meets code, you don't need to measure radon. However, For everything else, it's 15 minutes for each parameter. So you need to make sure that you're not collecting water reading every 30 minutes, every 60 minutes, or something like that. Otherwise, you will not be compliant. Sensors need to have the ability to be calibrated or replaced. So WELL requires that all monitors are calibrated on an annual basis. You want to choose a monitor that makes it relatively easy to keep the device calibrated. At Kytera, and I'm just using this as an example of one way in which you can do this. At Kytera, we put sensors inside these modules that can easily be removed and recalibrated and replaced. You can also, and there are of course other vendors that have a similar type of system. You can also take the device off the wall, take it to a calibration lab, calibrate it against a reference, put it back on the wall. You can have somebody come in with a reference monitor and kind of do a side-by-side comparison and adjust it that way. I think that's also compliant here using field calibrations. So that there are different ways to accomplish this. Just make sure that there is actually a plan for this, and that the monitor you're looking at actually has some kind of information and system about calibration. There are monitors that will claim to use sort of software calibration. I have some personal hesitations about this because sensors can physically degrade, and just trying to sort of adjust those numbers using software, I think there's some issues there, but we won't get into that. I've posted about this on LinkedIn before, and that's a discussion for another day. I think the one thing to keep in mind with that is that if you are reading this guidebook here, that is not one of the methods that is listed here. And so in kind of a best case scenario, you might have to haggle with the IWBI when it comes to actually submitting data that has been calibrated using some sort of software calibration. There are some requirements around the amount, basically not accepting, needing to have enough data. You need to, data loss is important. You can't just be missing several months of data. And then we come to the real meat of it here, which is the sensor technical specification requirements. And there is this table that goes through each of the parameters. So really what you want to be doing is looking at the spec of the sensor, looking at this table, and making sure that they are compliant. Right, you're seeing the same range, the same levels of accuracy or better. And there are some specific ones that you might want to pay attention to over here. There are parameter-specific sensor requirements. For example, TVOC, calibration gas, is ethanol. There is a target gas profile, which is a mixture of 22 VOCs that's been specified. So these are kind of some of the fine print that you want to be looking at when comparing these specifications to make sure that the monitor that you are choosing is actually compliant with this. Finally, there's at the last section here, there's a lot of data and information about the right way to submit sensor data. Because, of course, you can imagine the last thing the IWBI wants is that there are 2,000 buildings out there and each of them download data from continuous monitors, and they're in totally different formats. They're all submitted. One is a CSV, one is an Excel, one is a PDF, another is PowerPoint. And so there is a standard for how data must be submitted. And so I think this is also a really important thing to be looking at, which is it going to be easy to take the data from those monitors and submit it in the format that is required. This can be quite a time-consuming process. So with that, I would recommend everybody take a look at the performance verification guidebook. Remember to look at the continuous monitoring section, not the performance testing section. And the sort of key points, besides the regular parameters like PM, CO2, TVOC, make sure that the device has carbon monoxide and ozone, CO and O3. Otherwise, you will not be able to replace your performance testing, and you will still have to have somebody come on site and do a performance test. And even better, if it also has NO2, that's going to allow you to very easily get an extra point. Choose a device that is easily calibrated and that can provide a proof of calibration, an actual certificate of calibration for submission to show that this device has been calibrated. And make sure to choose a device that is compliant with the technical specification requirements that are listed in this table. Look at the fine print, make sure that you are choosing the right device according to this so that you don't end up with any surprises when you have installed 100 monitors in a building, submit the data for verification to the IWBI, and suddenly find that there's something in here that is not compliant. Hopefully this was helpful. Again, at Kytera, we make indoor air quality monitors, but it really and truly is my goal through these videos to provide insight and education and I've spent so many hours looking at these guidebooks and talking to people on their projects. It's really my goal just to kind of help translate some of this into English that's it's a little bit easier for everybody to deal with, and they don't need to spend as long in the weeds as I have spent over the years doing this. So I hope this is helpful, and be sure to be on the lookout for the next episode.